Okay guys, so let's see about this particular question on sequences. We have some numbers there that form some kind of pattern. We want to find the rule for the pattern. So if I just write it out again, a little bit clearer, and add those numbers on the top, we'll call those n, the positions, and the bottom is u of n. So in a sense we've got some inputs and outputs. So we go for the method of differencing. Okay, and when I mentioned inputs and outputs, it's interesting to see what kind of graph this makes. So the inputs are the n, the positions, so 1 with 5, and then 2 with 8, 3 with 13. As you can see that, you know, the actual heights of the points that we plot are getting further and further away from the n-axis, okay? So it kind of gives us an idea that it's some sort of curve here. So it's definitely not a linear pattern, it's not a linear sequence. So it's not y equals mx plus c. So then we go to the second set of difference, and this is the clue that it's definitely a quadratic. If we hit a constant number on the second set of differences, we can then choose our quadratic model. So it's not linear, y equals mx plus c, it's quadratic. But instead of x's and y's, we use n's and u of n's. And there's the general quadratic model, okay? Now the cool thing is that we already know one of those letters, a, b or c. These are the parameters of the model. If you think about y equals mx plus c, m and c told us about the shape of the model. Here we've got a, b and c for the quadratic, okay? And we take that second difference, which is 2, and we always divide it by 2. So whatever that second set of differences is, we divide it by 2 and we automatically have our a value. If you're keen to find out why, just YouTube it. You know, there's a nice little proof for why it's always divide 2 to find the a value. So now we know our model is a little bit more refined. U of n equals 1n squared plus bn plus c. Okay, so all we have to do now then is just find the values of b and c. All right. So remember when we went back to kind of linear equations and we had y equals maybe 3x plus c. 3 was the gradient, and you had to find c. The way to do it was to find an xy pair of numbers and substitute them in, and you'd find c. So we'll do a similar type of thing here, but it's not just one pair of xy numbers we need to sub in. So we're going to take n is 1 and u of n is 5 and substitute it into our model, our quadratic model. So u of n is 5 and n is 1. 1 into 1 squared plus b into 1 plus c. And if we just tidy that up, again, if we just rearrange it a little bit. Okay, so there's our first equation. Can you see we've got one equation with b and c? Now, if we could form another equation with b and c, we could solve simultaneous equations and find out what the mystery b and c are. Okay, and we're going to do that. We're going to take n is 2 and u of n is 8, and we're going to use the same model again. Okay, so just get a new page here. So n is 2 and u of n is 8, but of course n is 2, so what we're saying is the position is 2 and the second term in the sequence is 8. So n is 2, u of 2 is 8. Let's just copy across this formula from before, this model. Okay, and we're just going to substitute our two values of 2 and 8 into our model. So 8 is the output, or the u2, and n is the input, 2. Okay, just go and tidy that up. A little bit of rearranging. Okay, let's call that equation 1. Now bring back across the other equation we had. Can you see it there? 4 equals b plus c. Write it straight underneath. And then you've got to solve these two equations simultaneously. So find a solution that works for both equations. And you know, there's different ways of solving simultaneous equations. You could even reach to the calculator. The calculator has a tool there that allows you to solve simultaneous equations. It's under the algebra menu. So I'm just going to subtract equations because this is going to be quite an easy solution. In fact, it turns out b equals 0 for this. And so then find the value of c by substituting b equals 0 back into one of the equations. and you should find actually that the b is 0, therefore c comes out to be 4. Okay, so we found all our values for a, b and c. We found a by doing the differencing method, and then we found b and c by using simultaneous equations. Okay, so all that's left to do is to write out the model. This is the one we were basing it with. We had to find the missing a, b and c, and we found it. So the nth term u of n is 1n squared plus 0n plus 4. But of course we tidy it up mathematically, that's n squared plus 4. Okay, so there you go, that's how to find the quadratic sequence using nice simultaneous equation method for the b and the c.